This is a sputter deposition tool, which is a type of physical vapor deposition. With sputtering, the material you want to deposit is called a target, which is held within a source. The source and substrate are in a chamber seen through the window on the left. In the system at NanoFabrication Kingston, the source is at the top and the substrate is beneath it. The chamber is pumped down to high vacuum using a turbo pump. A small amount of gas is allowed into the chamber with a mass flow controller. In this case, the gas is argon. Up to 300 watts of DC or RF power is applied to the source, which ionizes the gas at the source to make a plasma. For argon, its plasma is this bright purple color. The plasma will attack the surfaces it contacts. Here, a strong magnet directs the plasma toward the target, and the ions cause small particles of the target to sputter off. After a short dwell time, the source shutter opens and the plasma is clear now. Sputtered material can now reach the sample. This system has 3 sources, 2 with DC power and 1 with RF power, which can all be used consecutively. In our system, the substrate sits on a tray at the bottom. The shutter opens and material begins depositing on the substrate. Our substrate tray can rotate to help even the coating and can be heated up to 500 degrees. The shutter closes again after a set time to end the deposition. Then the source shutter is closed and the plasma extinguished. All of these steps can be initiated in the software or programmed into a recipe that a user can execute with just the push of a button. We just watched chromium sputtering, but many materials are possible, including composites that are difficult to deposit in other ways. This is an example of a glass slide with 200 nanometers of chromium on it. The thin metal layer always gives a nice mirror finish.